The year was 1960. The Cold War was at its peak. The Soviet Union was locked in a fierce competition with the United States for dominance in space. Both superpowers poured resources into their space programs. They sought to achieve technological superiority. On October 24, 1960, a catastrophic event occurred at the Baikonur Cosmodrome. This event sent shockwaves through the Soviet space program and the world. The disaster, which came to be known as the Nedelin catastrophe, involved the explosion of an R-16 intercontinental ballistic missile. The R-16 was a powerful new weapon. It was intended to give the Soviet Union a strategic advantage over the United States. The missile was still in its testing phase. It was being prepared for a launch. However, a fatal combination of design flaws, rushed schedules, and inadequate safety procedures led to a horrific accident. During fueling and pre-launch preparations, the R-16's second-stage engine ignited prematurely. The exact cause of the ignition remains uncertain. However, it is believed that a stray electrical current or a mechanical malfunction triggered the engine. The result was a massive explosion that instantly engulfed the launch pad in a raging inferno. The Nedelin catastrophe was one of the deadliest disasters in the history of space exploration. While the exact number of casualties remains a state secret, estimates range from 74 to over 126 people killed. The victims included military personnel, engineers, technicians, and support staff. Among the dead was Marshal Mitrofan Nedelin, the head of the Soviet Strategic Rocket Forces. The Soviet Union was not alone in experiencing tragedy during the early years of the space race. On January 27, 1967, the United States suffered its own devastating setback with the Apollo 1 fire. This disaster occurred during a pre-launch test at Cape Canaveral, Florida. The Apollo 1 mission was intended to be the first crewed flight of the Apollo program. Its goal was to land astronauts on the moon. The Apollo 1 crew consisted of astronauts Gus Grissom, Ed White, and Roger Chaffee. They were strapped into their seats inside the command module, atop the Saturn IB rocket, for a routine test. The test involved a simulated countdown and launch sequence. However, a fire broke out in the command module. The fire spread rapidly through the pure oxygen environment. The Apollo 1 fire was a tragedy that shocked the United States. It exposed serious flaws in NASA's safety procedures and spacecraft design. The command module had a number of design flaws. These flaws contributed to the fire. The hatch, for instance, opened inward. This made it impossible for the astronauts to escape in the event of an emergency. The fire was a major setback for the Apollo program. It led to a thorough review of safety procedures and spacecraft design. NASA implemented a number of changes to improve safety. These changes included using a less flammable atmosphere in the spacecraft and redesigning the hatch to open outward. The Soviet Soyuz program, which aimed to develop a reliable and reusable spacecraft for human spaceflight, experienced both triumphs and tragedies. One of the most notable incidents occurred on April 24, 1967, with the Soyuz 1 mission. Cosmonaut Vladimir Komarov was piloting the spacecraft. It was the first crewed flight of the Soyuz program. Soyuz 1 encountered a series of technical difficulties during its mission. These difficulties included the failure of one of its solar panels to deploy properly. This reduced the spacecraft's power supply. Komarov struggled to maintain control of the spacecraft. Soviet engineers worked frantically to find a solution. Despite their efforts, Soyuz 1's mission was cut short. Komarov was ordered to return to Earth. However, during the descent, the spacecraft's parachute system malfunctioned. This resulted in a high-speed impact with the ground. Komarov was killed instantly. On January 28, 1986, the world watched in horror as the Space Shuttle Challenger exploded just 73 seconds after liftoff from Kennedy Space Center in Florida. The disaster claimed the lives of all 7 astronauts on board, including Krista McAuliffe, a schoolteacher from New Hampshire, who had been selected to be the first civilian in space. The Challenger disaster was a national tragedy for the United States. It sent shockwaves through NASA and the nation. The disaster grounded the Space Shuttle program for over 2 years, while investigators worked tirelessly to determine the cause of the accident. The investigation revealed that the disaster was caused by the failure of an O-ring seal in one of the solid rocket boosters. The O-ring, which was designed to prevent hot gases from escaping during the booster's ignition and burn, failed due to a combination of factors, including cold temperatures on the morning of the launch and design flaws. Section 5, the Columbia Disaster, a Fatal Flaw. 17 years after the Challenger disaster on February 1, 2003, tragedy struck the Space Shuttle program once again. The Space Shuttle Columbia, returning to Earth after a successful 16-day scientific mission, disintegrated over Texas during re-entry. All 7 astronauts on board, Rick Husband, William McCool, Michael Anderson, Kalpana Chawla, David Brown, Laurel Clark, and Elon Ramon, perished in the disaster. Like the Challenger disaster, the Columbia disaster was a preventable tragedy that highlighted the inherent risks of spaceflight and the importance of meticulous attention to detail. The disaster also underscored the crucial role that effective communication and a strong safety culture play in preventing accidents. The Columbia Accident Investigation Board, or CAIB, determined that the disaster was caused by a piece of foam insulation that broke off from the Space Shuttle's external tank during launch. The foam struck the leading edge of Columbia's left wing, creating a hole in the reinforced carbon-carbon, or RCC panels, that protected the shuttle from the intense heat of re-entry. Section 6. Space Debris, the Invisible Threat. As more nations and private companies venture into space, the problem of space debris has become increasingly urgent. Space debris, also known as orbital debris, consists of human-made objects that are no longer functional and are orbiting Earth. This debris can range in size from tiny flecks of paint to defunct satellites and spent rocket stages. The primary concern with space debris is the risk of collisions with operational spacecraft, including satellites, telescopes, and the International Space Station. Even small pieces of debris traveling at extremely high speeds can cause significant damage upon impact. Several approaches are being explored to address the growing problem of space debris. These approaches include developing technologies to remove existing debris from orbit, designing spacecraft and launch vehicles for greater debris mitigation, and implementing international guidelines and regulations to promote responsible behavior in space. Section 7. Lessons learned, enhancing space safety. The history of space exploration is marked by both triumphs and tragedies. Each disaster, from the Netherlands catastrophe to the Columbia disaster, has provided invaluable lessons that have shaped the way spacefaring nations approach safety. One of the most important lessons learned is the need for a robust safety culture that permeates every aspect of spaceflight operations. This includes fostering open communication, encouraging the reporting of potential hazards, and empowering individuals to stop work if they identify a safety concern. Another crucial lesson is the importance of rigorous testing and quality control throughout the entire life cycle of a spacecraft or launch vehicle, from design and development to manufacturing, assembly, and pre-launch preparations. Section 8. The importance of international cooperation. As space exploration becomes increasingly international and commercialized, the need for cooperation and collaboration among nations and private companies has never been greater. International cooperation is essential for sharing information about potential hazards in space, developing common safety standards, and coordinating efforts to mitigate the risks posed by space debris. The International Space Station, or ISS, stands as a testament to what can be achieved through international cooperation in space. The ISS is a remarkable feat of engineering and a symbol of humanity's shared ambition to explore the cosmos. It is also a testament to the power of international collaboration in overcoming technical challenges and advancing scientific understanding. Section 9. Conclusion. The future of space exploration. The human quest to explore the cosmos is an endeavor that is fraught with both promise and peril. While the tragedies of the past serve as stark reminders of the risks involved, they have also inspired innovations and advancements that have made spaceflight safer and more accessible. As we venture further into the solar system and beyond, we must remain vigilant in our pursuit of safety, always striving to learn from past mistakes and to anticipate new challenges. By embracing a spirit of cooperation, innovation, and unwavering commitment to safety, we can ensure that the future of space exploration is one of continued discovery and progress for all humankind.